Okay, so this question 2 by 64 is again taken from the Jail Merriam book. So with what minimum horizontal velocity u? So the horizontal velocity, which is u here, is unknown. Can a boy throw a rock at A? So this is position A, and have it just clear the obstruction at B. So it's just touching this obstruction at B. Okay, so in this question, what you need to calculate? You need to calculate this u, which is obviously the velocity in x direction at this maximum point here, and you're also given uh, the height here, which is 26 up the point A, and you're also given the height up point B, which is 16 here, and the horizontal distance between A and B is also given, which is 40 meter. And obviously, you know the value of the G, which is 9.81 meter per second square in the downward direction. And we know these equations, which we derived for the projectile motion. And these equations will be available in the formula sheet in the exam and also in the class test. So the first two equations are for the x motion, and then the second two equations are for the y motion. Now, as you can see in this case, that if someone throw a rock here in the horizontal direction, so this means that the that Vy, so the Vy naught is 0 here, and this u is actually Vx naught. So in this case, obviously we can use these equations. So we need to calculate the u, which is the ux, which you can calculate from this equation, because we know that the u will remain constant. So this is again u. Again, this is also u, and again this will also be u. So u is which is equal to vx naught. So the u is not changing. The only velocity which is changing is the y velocity. So in this case, as you can see, we can use the first equation here, which is this equation. If you use this equation, y is equal to okay, so this is our solution now. Y is equal to y naught plus vy naught t minus half gt square. So if you use this second equation here, now y is the final the final height, and y naught is the initial height here. So we know that the final height is 16, the initial height is 26, and vy naught is 0, and then you have minus half, and g is 9.81, and t here is t square. So from this equation now you can calculate the time which this object will take from A to B. So the time here that you can calculate is 1.428 second. Now, if you know the time, then you can use this equation to calculate the Vx naught, which is your u. If you use this equation here, x is equal to x naught plus Vx naught t. So x here is we know that x is at this location is 40, and x naught is 0, and plus Vx naught, which is our u, and then you have t, which is 1.428, which we just calculated here. So in this equation, the only unknown is Vx naught, which is our u, which we can calculate from this equation, which is going to be 28 meter per second.